X cubed equals 27.
Oh, x cubed
Equals 27.
27. All right, let me do one that nobody had. Everybody had a problem like this.
Yeah,
Nobody had this problem.
I think I had that exact problem.
I don't think so.
Maybe on the homework.
Maybe.
Yeah.
Yeah. I gave everybody like 64, 27, 8 on the test. Bless you. I didn't give anybody this one because, I mean, you should all know it's 125, well, how it breaks down, but just in case. True, but that's not the answer. How many answers must there be?
3.
3. We're more sophisticated now. I don't want just the real answer now. I want, in fact, the instruction said solve completely. So if you just said x is 5 here, no, what else could it be? So you got to bring that over. Little dude, big dude.
X minus.
Yeah, 1x, 1 5, 2 x's, 2 5s, opposite sign, product. So this you've got to use quadratic. Here's your real answer, x is 5. Here's your 2 complex answers from quadratic formula.
So what's the final answer? What do you write it as?
So here's x equals 5, or, so then you start doing quadratic, negative 5 plus or minus square root, blah, blah, blah. No, get you 2 complex answers. We are smarter now. We can get all answers to a problem. If it's got a 3rd power, there has to be 3 answers. If the 8th power, it's got to be 8 answers. Huh? Never. The big dude can never be factored. There's no numbers that multiply by 25 had to be 5.
What was your question?
If you could factor this guy, and you never can factor the big dude.
So you always have to use the quadratic.
Yeah.
I feel like the smile means no, but here, yes.
Well, the word always gives me trouble. You know, you got as a teacher, you got to stop and think. I mean, but if it's every cubic, the big dude will have complex answers.
Okay, for 1R, I'm guessing master root and e cancel each other out.
Yeah, no guessing. That's exactly right. Natural log is base e. It's going to kill e to something. So your answer is just x squared. Let me give you guys the answer key. It sounds like a lot of you guys actually did this practice thing. Hopefully this is all right.
Did you write this in blue?
Yeah, I handwrote every one of these. Whew! I'm tired. So let's see. Hopefully it's the same. I was so excited when I found the answer key. Yes, I like it. Sweetness. Looks right. Looks the same.
How many times did it take you to write this entire answer key?
What do you mean?
You wrote it in blue, right?
Yeah, and then I copied it in color.
Oh.
Yeah.
So you wrote it once.
Yes, thank God. There's no way in hell.
I'm just making sure.
Look at this. There's no way I would ever do that to myself when I'm like, I don't know how many people are going to show up.
Yeah, I think it
No.
was.
Aw.
Definitely want one of these.
Yeah.
Okay. That's like you were.
So even though nobody ever takes this advice, do not stare at this and agree with me.
Yeah, okay.
Because not only does that not help you, it makes things worse. You get false confidence. When you're like, I'll take any kind of confidence. No, you don't.
I'll take any kind of.
If it weren't for bad luck, I'd have no luck at all.
Number 2 you see was like. Right. Oh, no. The large size part. Small. difference or was one less work? Less work than the other?
By the way, tomorrow I'm going to have the spreadsheet of grades up here on the computer, and anytime you want to take a break from the test and come up, we can look over everything. Where your grade is, missing homework stuff, whatever. Cool?
We'll be too late for this homework.
Huh?
We'll be too late for this homework.
No. What do you mean?
Will we?
Well, I mean, if you did it and I say it's missing when it really isn't, you can show it to me. If you just never did it, then it's not like going to be news to you. You know what I mean? You decided not to do it. Yep.
Can you write down the formula for the squares?
So you mean Pythagorean theorem? Or, oh, for factoring cubes. Okay. Yeah. I can. You get it. Say again?
The homework is for today or tomorrow?
What homework?
The homework.
Oh, tomorrow. Yeah. Always due by the day of the next test. Just tomorrow. So the general rule for a sum of cubes and really the only difference, if this was a minus, this would be a minus and this would be a plus. Same, opposite, always positive. Oh yeah, I left the 5 out just because I think number 5 is overused. So on 1D there should be a 5 on the bottom. Say again? 1D. 1D is in dog.
Yeah, and then what do and then I'd be x plus 3 over x.
Yeah, the 5 should, oh, there you go. The 5 from that problem went over to that problem. Yep.
Is one there?
Just wandered. They do that sometimes.
24 z squared minus 28.
Whoa, what?
Yeah. 24 z squared minus 28 z minus
Minus
12.
12.
Now, okay, pull up the 4, you get 6 z squared minus 7 z minus 3. And you split that up. The middle terms are negative 9 and positive 2. So now you get, yeah, 12z. You get 6z squared minus 9z in one parentheses, and then 2z squared minus 3 in the other.
Okay.
So you pull out the 3.
Yeah, keep going.
Oh,
Yeah.
well, okay, I multiplied the 3z and the 4 together.
But see the 4, what is the 4 multiplied by? Everything in here. And why would you multiply in a factor problem? So if you it would be really rare to have to multiply when I'm asking you to factor something, right? Because factoring is the opposite of multiplying. So that 4 just stays. He's done. You're focused on the inside. Get the inside done, and then you're done.
Okay. That's
Well,
what
if the inside you have to take out and then goes out and it's with the 4.
And it multiplies because it's 4 times this. So if there's another factor of 2 you forgot to bring out, now it'll be an 8 out there. Yep. me see who else. Real quick. It has nothing on it. It's considered fine. I might have some cocoa on there for my moon. I just didn't have time to look at it. I want to give it back to you. Genesee. Okay. I believe it's been like 5.5 weeks. It's crazy.
Jared, y'all don't actually how to solve this, but when you move to the over to the square root part, doesn't the 4 stay in the parentheses since it's
Doesn't have to.
given
No,
one fraction?
it doesn't have to at all.
So either way it would be correct if it was.
So tell me this real quick. Is x to the third to the fourth, is that different from x to the fourth to the third? Are those different? No. So if I have 27 to the, was it negative 27 to the 4/3? That is the same thing as negative 27 to the 1/3 to the 4th. Isn't that the same thing? I could switch these, but why would I? I don't want to take the cube root of 27 to the 4th. Holy shit. I'd rather take the cube root of 27 and then raise it to the 4th power. Yeah. Sure.
How do you do 3i?
Well, let me tell you. Went out on the front porch and I sat down for a while. Let me see. Which one? 3i?
Yes.
What? 3i. There it is. Okay. Oh yeah. Boy, I sure skipped a few steps. So you have to add the 2 first,
I don't care if it's a road.
and then you take ln of both sides.
All right,
ln 11 equals x plus 1 ln 3, and then you divide by ln 3. And that catches you up to where I started. So on one, I'm sorry, what was it? 3i. I remember back. Hello. That's right. The couple of steps that I skipped was add 2, and then take ln. And then divide by ln 3. And that gets us caught up to where I started. Right? You got to isolate that thing, then you can attack it with an ln, so the power comes down, and then you can divide by that ln 3.
Why did you choose ln again?
It's got one less letter than the other option. So you could use log if you want to. But really, it truly is just that there's one less letter. To be really, really honest, there's a little more to the story because ln is just more generally useful in problems that deal with these. But at this point, I mean, you could use either one.
I'm just confused as to how I'm supposed to understand or know that I'm using ln or log anyway. Like when I look at that, like why solve this?
Okay, so do I have an operation that will free up this poor little variable? Is there something I could do that would free it? It's stuck right now inside of an operation. Is there an operation I can apply that would make it free? What would I do?
For the x,
To get the x by itself.
130.
What would I do to both sides to kill
Oh, square.
cube it? All right. Now, if my variable is stuck up here, what's the only operation that can undo that? That can bring it down, that can free the variable up? A log. In which log do I almost always use, me personally? I use ln because it's got one less letter than all the other options. Right? It doesn't matter what log you use, to be honest. Historically, we use ln or common log, log, with base 10, understood, because those are the two that are on the calculator. Calculators keep getting better and better. which students tend to believe means you got to know less and less. Unfortunately, that is not the case. You still have to understand shit. You know, part of my theory about the way students are today is we got Google. You all got it in your pockets now. I remember back when it was like science fiction to have a computer with you everywhere you went. And now, and you're all like, good Lord, Jeff, you're old. But I feel like everybody thinks everything's been done. I just got to find it. Why would I care about how to do something? I can just find somebody else who's done it for me. I think that's a part of what's going into how students behave in classes. So part of it's not really your fault. The other part is you're old enough to realize that's shit going on, and you can clamp that shit down, right? Little rant for you. Yes?
On that problem, when you change it to like a log form, don't you have to switch the numbers around? Like, it would be like 3 to 5 equals X or something.
Here? This?
Yeah.
So if I take ln of both sides, I just take ln of both sides. Just like here I took the cube of both sides, did I? Here I'm going to take ln of both sides. Then that can come down. And I can divide by ln3 and be done. So x equals ln5 over ln3. I am not rewriting an exponential into a logarithmic form. I'm using natural log to solve the equation. Different idea. Yeah.
So the vertex is negative b over 2a,
Careful.
negative x,
Good.
and you plug it in
To find
the vertex.
the complete vertex point. I like it. Okay,
And
good.
then the axis of symmetry, I'm confused.
So if I have an up and down parabola, the axis of symmetry would be a vertical line. So it'd be x equals the x part of the vertex, because it's got to go through the vertex. If it's like this,
Okay.
the y equals the y piece of the vertex.
So the axis of symmetry is essentially whatever you got when you.
It's related to the right part of the vertex.
Okay, exactly.
Yeah, so if my vertex is 2, 3, and it's opening like this, x equals 2 is going to go right through 2, 3.
Okay.
If it opens like this, y equals 3 is going to go right through 2, 3, yeah.
I mean your axis. Okay, and then the intercepts is just when you plug in your like pretty standard points or whatever like works with your problem.
No, intercepts are when you make, x-intercepts are make y0, y-intercepts make x0. Yep, always.
For 12 days, if you put it 2 ways for
Oh, all right. So how do I rationalize the bottom of something? So on the bottom of this one is cube root of 4a. Doesn't really matter what's on top. How many a's do I have already? 1. How many more do I need so the cube root can work? 2. So that's where the a squared part came from. Now, I don't need 2 more 4s because 4 is already 2 2s. How many more 2s do I need? No. It's a cube root. I need 3 things. I got 2, so I only need 1 more. I mean, don't make that more than it is. And don't make it less than it is. I don't remember what that shit was. It doesn't matter. Don't just multiply by this. The only time that works is when it's a square root, because then you need 2. I've already got 1 of whatever, so I multiply by the same thing. It doesn't work for every root. Cube root needs 3 of everything. So you just say, how much do I have? Let me give it what is missing. How much do I have? Let me give it what is missing. It's not difficult. You have to look at it as, why does that make sense that that's what I do? Instead of, how do I memorize to do that? Try to memorize everything, you're not going to make it very far in math. Because you only got so much space in your head that you can access fully. They don't make that limitless pill yet.
I to the third is I.
Well, all right, no. I don't know how you guys memorized this.
Is it negative?
Yes. So I have the first is I. I have the 0 is 1. I have the first I squared is -1. So when you multiply by one more I, you get negative I. Joking there about an I for an I.
So, sorry, just to finish where I came from, so part 12E, the reason that it's I is because the exponent is negative.
Yeah, so this has got a couple things going on. It's a negative power, so that the 1 over I to the 23rd. Then you can figure out what this is on its own. So yeah, it's going to be related to I cubed because that's the remainder when you're divided by 4. So that's 1 over negative I, right? And then what do I do with this? I multiply by the conjugate. So it'd be I over negative I squared, which is I over negative 1, which is I.
And you multiply by the conjugate to the rationalize the bottom.
Yes, and watch this. I can go backwards with this too. What must I to the negative 1 be? So we go here. I of fourth is 1, right? So if I go back from 1, I should get to negative I. So I to the negative power is negative I. I to the negative 1 is negative I. So I can break this up as I to the negative 1 to the 23rd. So that's negative I to the 23rd, which is negative I to the 23rd, because 23 negatives makes a negative. Oh my God. So that's just another way to do it. I'm not saying you have to do it that way. This way makes sense, but right here, you've got to multiply by the conjugate to get it in the right form. That was a neat problem.
How would you do I to the 63?
Same way you did I to the 23. What is 63 divided by 4? What's the remainder?
3.
3. So I-63 is the same thing as I-3, which you just talked about. And again, it's just because, why do I divide by 4? Because every time I do 4, it's a rotation. So why would I rotate that many times? Let me just divide a bunch of rotations out and figure out where I really stop.
Okay. So you divide by 4.
And see what the remainder is, and that tells you
I divided
which...
by like 5 and saw the remainder.
Don't do that.
Okay.
The pattern isn't every 5th one starts over, it's every 4th one starts over.
Okay.
Yeah.
Can we do another example of the I?
They're all the same. So I to the 401. What do you get when you divide that by 4? What's the remainder? 1.
So it's always divided by 4?
Yes. Why? Because the cycle is every 4th one. 0 with power is 1. When does that start over again? At the 4th power. Every 4th power it starts over again. So somebody telling me to turn 8.5 times. Turn around 8.5 times. I'm like, let me just turn around a half and I'm done. I just took all the... If I turn 8 times, I'm going to end up here again. So dividing by 4 gets rid of all those extra spins. And then you can just see where do I end up? Turn around 28 3/4 times. Well, let me just turn around 3/4 and then I'm freaking facing the... Why would I turn around all those other times?
Can you go over 1L? Because it's been a while since I've done that.
Oh yeah, what's the shortcut for taking the roots of things like this? So 5th root, g to the 8th, w11 m squared. Remembering that 5th root is actually a 1/5 power,
What question is that?
1L.
Oh, L.
Who remembers? What do you do?
How many times 5 can go into 8?
5 goes into 8
Once.
once with 3 left. Really, why is it happening? Because what is g to the 8th? It's g to the 5th times g cubed. Well, this is g, and this ain't got enough to do. So what's the shortcut? 5 goes into 8 once with 3 left. 5 goes into 11 twice with one left. 5 goes into 2. Nope. So they're both left. Done.
Would you put the actual, would you put the multiplication symbol or just say the way it is right now?
Huh?
No, I'm saying like for GW2, okay.
Sure.
Wait, where'd you get the GW2?
5 goes into 8 once
Yeah.
with 3 left over. And again, G to the 8th. Isn't that G to the 5th, G to the 3rd? And what's the 5th through to G5? Straight up G.
So the W squared is 5 given to 11 twice, and then the one in there is the one.
Because this is W10 times W. 5th through W10 with W squared, and this is an extra W. I like it.
Did you already do 7?
No. Oh, did I say in class? Oh, yeah. All right, here we go. So number 7 is the matrix problem. My name is Neo. So everybody should know how to set the matrix up. Right. So at least double check that shit. Because if you write the wrong thing down now, you are screwed. So first thing, all right, what's the goal again?
1 0 0 0 0 1 0 0 1.
With numbered run on, right? All right, so somebody notice, do I want to divide this one by 3 to make a 1 there? If I did, would I make a bunch of fractions that you have to work with the whole way through? If I force you to, should you be able to do it? Yeah, you should. But dear God, we're not going to do that shit.
Didn't we just move the second
Thank
row
you.
to the first row
Yes,
first?
of course. There is a 1 here. It's -1, but I can multiply by a negative. Why do I actually don't want to do that yet? Because I'm going to use this to kill these. These are both positive. Might as well leave that one negative for a minute. Does that make any sense? If you want to, you can make it a 1, and then you got to multiply by -3 to kill the 3. Why?
Yeah.
So I like this. So switch row 2 and row 1, right? Or it doesn't really matter, but yeah, it does. So you get -1, -2, 2, 8, 3, -1, -5, -7, 5, -2, -1, 11. All right. So I basically just gave away the first step. Now, to be really honest, you don't have to start with this first column. You could start with this column. It's got some nice stuff going on, right?
Multiply by negative.
Yeah, if I multiply by a negative, these would kill each other, right? For example, and then I can use this to kill whatever's left, blah, blah, blah.
So you're allowed to just switch rows? Or-
What do the rows mean? In fact, where did I get that from?
It's an equation.
Yeah, and did I have to write the equations in the order that I did? Did I have to? No. So switching rows is really just going, let me just say the equations are just out of order. I could do that. Doesn't change the answer.
And confirming we can divide rows by themselves too, as long as we do not.
What do you mean by themselves?
So like if I wanted to divide row 2 by 2, I can divide.
Oh yeah, you could divide a row by a constant, sure.
Yeah.
Okay. You just cannot multiply 2 rows together. I've seen people do that. Why? Because if I take 3a minus b minus 5c equals -7, and you're going to multiply that by, one thing is, how do you even define this? multiply that by negative a minus 2b plus 2c equals a. How do you multiply two equations? So you cannot multiply two rows together because rows are equations. And what the shit would this be? I mean, you can only do the things to rows and between rows that you can do to equations, in between equations. You can multiply them, you can add them, you can subtract them from each other, blah, blah, blah. You can multiply one by a number, but you can't multiply a row by a row. It doesn't make any sense. So don't get a zero somewhere and go, oh, I just multiply the other, I get zeros everywhere, yay, no. Okay, so what do you guys want to do? Do you want to work with the first column?
Yeah.
Yeah, okay. So how would I kill this 3?
Now the first one,
Yeah, 3 row 1 plus row 2. Put the answer where? Row 2. I don't want to lose my 1. So if I multiply this by 3, I get negative 3, negative 6, 6, 24. So then I get negative 3 and 3 is 0. Negative 6 and negative 1 is negative 7. 6 minus 5 is 1. 24 minus 7 is... Cool. I'm done with these, right? Let me see if you guys can handle this, because I don't want to write a lot. How do I kill this?
Same thing.
Multiply row 1 by
5.
5. Aw. Should be good. What happened to you? You were the chosen one. Okay. So if I multiply this by 5, all right, screw it. Well, that was neat. I thought I was gonna catch. Look at all these things that kill. Dear Lord. All right, just gonna have to do it in blue again. So this would be negative 5, negative 10, 10, and 40. All right, if I multiply that by 5. So then negative 5 and 5 is 0. Negative 10 and negative 2 is negative 12. 10 minus 1 is 9. 40 and 11 is 51. And the first row, let me go ahead and multiply the first row by negative. Is that cool? Maybe I don't need to, but I'm going to do it anyway. I don't know if you guys see this, but all those are divisible by 3. 5 plus 1 is 6, so it's divisible by 3. So I can divide row 3 by 3. Let's divide it by negative 3. Haha. 4, negative 3, negative 17. Now, there is a definite better column to move to next.
Multiply row 2 by...
So which column are we going to work on next? Yeah, why the third column? There's a 1 there. Now you could multiply this by 2 and add it to this guy, because 8 minus 7 is 1. If you really wanted to go in order of columns. You remember we talked about that? You can make a 1 if you want a 1. Or you can multiply this by 4, this by 7. Kill them. Nothing wrong with that. Which one do you think you would see? That you would think about? You're like, you gotta be there to find out, man. I don't know. What would you do? All right, I don't know. What do you guys want to do? I was like, do I said, all right. So if I take this and multiply by 3, I'll kill this. So if I take row 2 times 3 plus row 3 and put the answer in row 3. Huh? No, I don't want to lose my 1. Yeah, oh, I see. I remember I can just switch rows.
Oh, you can switch rows.
So right now I'm going to get a 1 there, but I can just switch it down there. Not a big deal. It's more important that I don't lose that one right now than that it is in the other place. Wait, I'm going to do that too. So 3 row 2 would be 0, negative 21, 3, 51. Add that to row 3, so I get 0 and 0 is 0. Negative 21, 4 is negative 17. 3 minus 3 is 0. 51 minus, it's interesting. 51 minus 17 is 34. Oh, good. All right, I was overthinking it. And then how do I kill that guy? I might as well just finish working in that column. Who knows? How do I use that one to kill that guy? What would I multiply this row by? So it will kill this when I add them together. 2. Because then there'll be a 2 here. Add those together. It's really the fundamental idea. If I have a 1, I should go, thank God. Because I can multiply it by whatever I need to kill whatever's around it. That's the whole idea. So doing this equations by hand sucked because it was very, like open to doing it several ways. Here, find a 1, make zeros. Find a 1, make zeros. Right? It's very focused, our process that we use. So if I multiply this by 2 now, twice row 2, plus row 1, put the answer in row 1. I get 0, negative 14, 2, 34. 0, 1 is 1. Negative 14 and 2 is negative 12. 2 minus 2 is 0. And 34 minus 8, 26. Now, before you freak about the middle column still looking gross, what do you always look for? You can divide row 3 by negative 17 and get a 1 here that can then kill those guys. Cool. So I divide this row by negative 17, I'll get 1, negative 12, 0, 26. 0, negative 7, 1, 17. 0, 1, 0, negative 2. Then I can multiply by 7, kill him. Multiply him 12, kill him. It'll be out of order, but who gives a shit? I can flip them if I wanted to. Do you guys see what's happening? Multiply by 7, I can kill him. The zeros will not screw with the other shit up there, thank God. I won't lose the 0, I won't lose the 1. Same thing here. I won't lose the 0, I won't lose the 1. This is my laser. I don't know if you guys see what I mean. If I multiply this by 7 and add it to this guy, I'll get 0, 0, 1, 3. If I multiply him by 12 and add it to this guy, I get 1, 0, 0, 2. And then I can just switch these around. Right, what's this say? X is 2. What's this say? I'm sorry, A is 2. Just remember this. A, B, C. What's this one? C is 3. And B is negative 2. It's just out of order, so you got to make sure which variable it's referencing. If I flip them, then I just go A, B, C. Bam.
It's a possibility to leave it like that, just knowing the order. Not the ordering like the first.
Yeah, you could leave the matrix like this as long as you tell me what the hell the answer is. Yeah, don't just stop here. But we just picked out the answers. Doesn't really matter what order these 1s and 0s are in, right? If it's in that order, then I know A, B, C. Here I know A, C, B because they were out of order. Who cares? I've got all 3 of them. That's what I need.
So for, 3 times row 2 plus row 3, you did, times negative 3,
Where are we at? Sorry.
the blue one at the top? Yeah. You did times negative 3.
No, I did times 3. So 0. 3 times negative 7 was negative 21. 3 times 1 is 3. 3 times 17, 51.
Oh, okay.
And that's because these other one was already a negative 3. I didn't want to, yeah. I want them to cancel.
One to N.
So 1 then. Oh, we did talk about that earlier. If you rewrite that in fractional notation, then you just add the powers. 1n, right? N is in Nancy?
Yeah.
Okay. So it'd be, what's the cube root of x? X to the 1/3. Because what's a cube root do to something? Cuts it in thirds. 4th root of x cubed would be x to the 3/4. And then you can just add the powers. That's, again, that's another reason. I mean, root notation really does suck. We don't really need it. It's just that historically they both kind of bubbled up, so we're like, we'll use both of them. If I had a time machine, math would look a little different. Of course, I understand that some of my theories are probably wrong, so I wouldn't do that. If I made a time machine, I'd do other things. Make sure Hitler was more interested in art, for example. Probably visit 2016. Do some stuff there. To be, the length of a certain rectangle is 2 more than 3 times the width. Okay. So we got this here? Is my camera still going?
Yes.
Okay. So the length, so you kind of gloss over the 2 more and 3 times and 261. All that doesn't mean shit. The first thing you're doing, drawing your picture and identifying your players, right? Length and width. Which one of these is just going to be X or just a letter? The length is 2 more than 3 times the width. The width is X. So the length is dependent on the width. Call the width X. What's the length?
3 times.
Yeah, what's 3 times the width? I call the width X. So what's 3 times the width? I call the width X. So what's 3 times the width?
3x. 3x.
3X. Good.
Oh,
And it's 2 more than that.
plus 2.
One of them is just X. The other one is based on that. Almost all the time. That's a really good idea to label your picture, because otherwise you'll go only halfway around the picture. But in this case, it's really, I don't really need all those to be honest, because this one's talking about what geometrical aspect? Area. What's the area of this square, or this rectangle? Good job, Joe. I know it's 261. What's the area of this? Good. Length times width. And you see what kind of equation this is going to end up? So I probably need to do what? Factor it. You can do quadratic if you want to. You see that? Draw the picture, identify the parts, give them math names, and then put them into the equation that they asked for.
This is homework to turn in.
So did you have the homework in your office?
Huh?
The homework from yesterday is in your office, right?
Homework from yesterday.
The 13.
Hmm? Oh, the worksheet, yes. Okay.
Sorry.
So I didn't get a backside to the practice test.
Oh, that sucks. Oh, the answer. Oh, shit. I love my printer. Likes to remind me that I'm not really in control. Everybody else, make sure you got two sides to the answer key for your practice final. I love that. And it's not out of ink, but it printed some of yours in black, which is not a big deal, but it's just like, it's just a little way it's screwing with me. Human, guess what? What?
Your printer said fuck your color pen.
Pretty much. Nice, dim blue. Nice. Screw that. That's what I think their printer sounds like. Huh? Oh, 3D printers. This seems pretty cool. Like in Cloverfield Paradox, and they print out a gun. You gotta go print out a gun. And there's a,
Have you seen Ocean's 8?
no, that sounds like a good idea. It's the one with there are women that do that.
Yeah. They like had a bunch of jewels made with user zirconium.
They were 3D printed? Oh. That's interesting. I like that. Yes.
What's happening? Are we just more questions? Okay.
What? Did you say what's happening?
Yeah, people are just leaving.
Well, some people didn't even come, so I mean,
Okay.
you know, they could leave whenever they want to.
Oh,
So,
so the class isn't over?
No.
Okay, I wasn't sure what was happening.
What happened to the 5? Oh, yeah, exactly. So there's a 5 that should be here. You said this earlier. Okay. And that 5 shouldn't be there. So yeah, I tried to cross it here and it didn't. But I wasn't. So that 5 just kind of meandered over here. It's like, what is that?
Yeah,
No, man. Just a mistake.
No, I can remember.
Example I always give is Steph Curry's pretty good at basketball, but he misses shots every now and then. I'm not saying I'm the Steph Curry of math, but yes.
I was gonna say, hopefully the 50 ones that do come to class will cross the phone.
Almost. I never hope for that. I do appreciate when people get what they deserve, yes. But I always hope for every student to pass. Yes.
That's it.
Putting on in the calculator. Finding the x-intercepts and vertex on.
Oh, yeah, so that's where you put y1, you put the function in,
Yeah.
and
then
define.
and once you get that, that's when I
Now, are you using, to get the x-intercepts, you use the 0 function. When they ask you left bound, right bound, guess, those 3 questions.
So y equals, we got that, the decimal problem on one of the tests.
Oh, yeah.
So when we graph it,
I hit second calc. Second trace, to get to calc, and I can 0 would be the x-intercepts. It's going to ask you, so you pick one of the x-intercepts and you do to the left of it, enter, to the right of it, enter, and then you put a guess, enter. There you go.
so you have to go just anywhere to the left, right, and center.
Yeah, find what you're looking for, and it's going to say left bound, right bound. It gives it an area to search, and you give it a good guess to start with.
Gotcha, okay.
So if you took calculus, you'd actually see the algorithm it's using to find it.
Okay.
And then the vertex would be the same idea. The vertex in this case would be a maximum. So if you go back to second calculus, a maximum. It's going to ask you 3 questions again: left bound, right bound, guess.
And you just do it on each side of the vertex you can see.
Yep. Mm-hmm.
I didn't really go over the parabola, circle, ellipses, and stuff. How do you tell whether it's a circle or not?
So you, all right. That was like the first thing we went over. But basically, a circle will look something like this, where you have a plus in the middle and they're both squared. Ellipse would be where the x and the y don't have the same numbers associated with them. That's an ellipse because it's plus, so it's still a closed image. It's just that it acts differently in the x and y direction. So that's exactly what an ellipse is. And this way it goes maybe less, and this way it goes more, or vice versa.
Okay, so like circle is when it's not gonna be divided by something?
I mean, it could be, but it would have to be the same exact thing. I can write this like this, right? Because then I can multiply by 9 and get it back up there. So I just said this so many times. A circle has to act the same way in the x and the y direction. It's got to be perfectly symmetric. Here, the x and the y direction are different. So that's going to be an ellipse. And to make a hyperbola, it just has one thing. It just has to have different signs on the x and y squared. That would be a hyperbola. Well, there's more detail for each of those, but